Welcome to this video. In this video, I will try to explain how to solve and how I would solve a K-map, and specifically when you have down curves. So here you have a function, and you can see the function is defined as a product of sums, and we have the list of max terms, and we also have the list of don't cares, which are the conditions that we don't care whether they're 1 or they are 0. So first of all, what we're going to do is we're going to draw a K-map. As you can see, this is a 5-variable problem. So I'm going to draw a 32-cell K-map. So the first thing you do when you draw a K-map is decide where are the variables. So there are different approaches to this. My approach is that I like to start with a known pattern. The known pattern that I like is this one. I like to place min term or max term 0 here, 1 here, 2 here, and 3 here. And this pattern will repeat all the time. So now, since I reached number 3, I am going to go to number 4 here, and then I'm going to move to the bottom for number 8, and I'll put number 12 here. Then I'm going to start going with this. This is going to be 5, 6, 7. Here would be the 9, the 10, the 11, 13, 14, and 15. I can do the same on the other side. And on the other side, of course, I'm going to start with number 16. And I'm going to follow the same pattern. 16, 17, 18, 19, 20. And I'm going to move from 20 to 24 and to 28. Now, one thing that I like to do when I solve K-maps is I like to not put all the numbers. That's because it helps me do it faster. So what I'm going to do is I'm going to erase the numbers that I don't usually write. So these are the numbers that I usually put in my K-maps. The reason why is, well, the first one, 0, 1, 2, 3, is to remind me of the pattern that we are following. The next numbers is to easily locate any number. So for instance, suppose you want to locate number 21. So for easily locating number 21, you can go and find number 20. And of course, you're going to know, since you already know the pattern, that number 21 is going to be this cell. And then if I want to go to, I don't know, number, let's say 25, well, for number 25, of course, I try to find the number 24, and then this would be number 25. And this can apply to any number. Once that you have decided your pattern, what you need to do is you need to establish the variables. From number 0 to number 1 is the least significant variable, so it's variable zeta. So zeta is going to be here, but it's also going to be here. Then for variable y is going to be the variable that has the value of 2. So variable y is going to be located here. Variable x is the one that has the value of 4, so x is going to be located here and here. And next is variable w, and w would be located over here and also over here. And finally, variable v. So variable v is going to be located on the whole right side of the map. Okay, next thing you want to do is, of course, you want to locate all the min terms or max terms according to what you're trying to solve. In this case, I'm going to solve for max terms, so I'm going to locate the zeros. So the zeros, according to the expression that I have above, is number 0, number 5. So again, since I don't have 5, but I already know the pattern, it's going to be 5 here. 6 is going to be here. Then I'm going to go with number 9. 9 is going to be here. Then it jumps to number 21. So 21 is going to be after 20. So it's going to be a 0 here. Then number 28. So here is going to be a 0. And the last zero would be number 31. So it would be 28, 29, 30, 31. So those are the zeros. Then I'm going to go with the dunkers. The dunkers are number 2, number 12, number 13, 14, and 15. Number 25 and number 26. So this would be the first part to solving this schema, locating the zeros, and if this is a function within complete specification, which in this case it is, we go and locate the dunkers. Next, what I like to do is I like to erase the numbers. The numbers can be a little tricky because you might get confused, because remember you are going to go and name the number of groups that you find later. So I like to erase them after I have located the zeros and dunkers. Again, this helps for clarification. It is not necessary, but again, this is the way I like to solve the problems. So now we're going to start following the algorithm. And the algorithm, the first thing, if you remember, it says that you need to locate the zeros. So we have already done that. Next thing you want to do is you want to locate the largest number of zeros, which in this case, the dunkers, we are going to consider them as zeros, okay? So for this part, we're going to think about for instance, all these, we're going to think about them as zeros. So I'm going to try to locate, according to the algorithm, I'm going to try to locate a group of 32 members. And of course, we already know that it is very hard to find 32 members, but my recommendation is try to force yourself to trying to find the largest possible number of groups, because it helps you remember that you need to start finding the largest groups. So of course we don't have any group of 32 members. Then we go and find 16 members. And what we try to do is, since we have two maps, one possibility would be that one map is fully completed with zeros or dunkers, or that we have 8 zeros or dunkers in one area and 8 on the other map. So for instance, you can have 8 zeros here and 8 zeros here, and this would be a group of 16. And of course you can see in this map that this doesn't happen. So next we're going to try to find groups of 8. So 8 members, again, you can have 8 members in a single map. So we try to find it, and here we have only 2, 3, 4, 3 here. So we don't have any group of 8 zeros. We go to the other map, and again, we don't find any numbers or any groups that have 8 zeros together. But we try to find 4. So for instance, here we have 4 dunkers, and in order for this group to be a group of 8, we would have to have another 4 zeros or dunkers here. So again, we don't have a group of 8. So now that you have thoroughly tried to find groups of 8, you're going to try to find groups of 4 members. So for groups of 4, you can try to find them in one side. Here, this would be the first group that I find. Now, if you do this on the exam, it's okay. But another recommendation is that if you find only dunkers in one group, it is not necessary that you include them. So if you omit this group, it is okay. Another group of 4s in one side of the map, I don't find them. I have 3 here, I have 2 here, I would need to have 2 here. I would need to have a 0 here or a dunker in order for these 2 and these 2 also to be a group of 4s. But we try to find groups of 2 that are the same in one side of the map and another side of the map. And we can see on the right side of the map that we don't have 2 zeros or dunkers together. So it is impossible for us to find a group of 4s since we don't have any group of 2s in the right side. So this would be it for groups of 4. Next, we try to find groups of 2, two members. And of course, we find a lot of members. And here's the important part. Remember that I explained to you that you need to not discriminate any group, okay? But if you find two donkers only, you can omit that group. So for instance, I find this group here. I'm gonna name it as my group number 2. I have these two here over here. This would be my group number 3. We have, and notice that I'm focusing only on the left part of the map. So here I have another one with this one, but I'm not gonna put it because of the color. But since I already need to change the color, I'm gonna change the color, and I'm gonna put this group over here, which would be my group number 4. And I'm going to put this over here, which would be my group number 5. And I'm gonna change colors again. And I'm gonna put this 0 here with this don't care here, and I'm gonna put this as my group number 6. Okay, and I think I have all the groups. I don't find any other groups of 2 in the left side of the map. And I'm gonna try to do the same with the right part of the map. And of course, we're going to see that we only have zeros. They don't have any adjacent members with them. So you might be tempted to go and find groups of 1. But again, try very hard to find groups of 2 when you're trying to find groups of 2. So this 0 here, actually it's adjacent to this 0 here. So I'm gonna try to put it, and I'm gonna put it with this color. And so this one here and this one here would be a group of 2, and this would be my group number 7. Then this group here, this 0 here with this don't care here would be a group of 2. This is not being redundant. Even if this don't care is in a group of 4, this is alone. So it is not being redundant. So this would be my group number 8 with this one here. This 0 would be with this don't care. So this would be my group number 9. With this one here. Notice how I put the number 9 in both sides of the maps. This is for you to not make a mistake and think that this one here is only a group of 1. Remember, since the number 9 is on both sides of the map, it's the same group, it's a group of 2. Then this donker, remember I said we don't need to group donkers, but this donker is also adjacent with this 0. And this 0, even if we have it, this 0 grouped with number 5, we are finding groups of 2, and group number 5 is also a group of 2. So you don't discriminate this group. So we also need to put it, I'm gonna put it with a different color. So this over here, which would be my group number 10, with this over here, would be my group number 10. And this don't care is lonely. So this is not a group of 2. Next, we have already found all the groups of 2 members which are adjacent. So the final step is trying to find groups of 1 group, which is in this case would be 1, 0. But in this case, we don't have any group of zeros or any 0 which is lonely, because this is a donker. And hopefully you understood why I could have, or you could have, omitted group number 1. You could have omitted group number 1 because they are only donkers. And you will see on the solution that this group will not most likely appear. So it's the same here. I can put a group over here it doesn't matter, it wouldn't be incorrect, but it is impossible that this group, let's suppose that I name it group number 11, so it is impossible that group number 11 is going to be part of the solution, because this is not a zero. And at the end, what we try to do is try to find as least groups as we can, that these groups cover all the zeros. We don't care about dunkers. Does it make sense? So in this case, again, I'm going to try to find groups of 1, and I don't have groups of 1. Okay, so this would be the first part of the algorithm, to find all the groups. Okay, so what happens next? So next, we are going to mark with an asterisk all the important or all the essential members. So the essential members are the zeros or ones that only are grouped with one group. So we, again, start by looking at each and every zero in this case and see if they have only one group. So for instance, we go with the 0, and this 0 is grouped by number 6, only by number 6. So this has an asterisk. So next would be this 0 over here, and this 0 is grouped by number 2 and by number 7. So this does not take an asterisk. This 0 also is grouped by two groups, number 4 and number 3. Next we go with these donkers. We don't check donkers, we only go check zeros, and so we don't have any 0 here. We go this 0. This 0 has group number 5 and group number 10, so we don't put an asterisk. And finally, we have on the right side of the map, we have 3 zeros. And these 3 zeros are grouped only by one group, this 0 by group number 8, this 0 by group number 7, and this 0 by group number 9. So we put an asterisk. Very good. So what this tells us is what groups must be part of the solution. Okay, so now we're going to start building the final function. So the final function, it's going to be equal to, and we start by the largest groups. So in this case, group number 6, or the first groups that we found. Of course, that has asterisk. So we start with number 6, group number 6. And once we put it on this part of the function, since these are essential members, what you should do is you should cross the zeros that are included by that group. Be careful, not only by the asterisk, but by the whole group. So in this case, this 0, this asterisk has group number 6, which we included here. So I'm going to cross this 0. This 0 is already being taken care of. Next, we don't have any other asterisk over here. So we go to the right side and we find group number 7. So we put dot, be careful. Oh, hold on. This would be dot, group number 7. Now be careful because this is a dot, and that's because we're in zeros. So dot 8, dot 9. And by doing this, again, you need to cross all the zeros that are covered by this group. So group number 7 covers this 0. And be very careful. This 0 is the one that has asterisk. But notice that this 0 does not have an asterisk. It doesn't matter. Group number 7 includes these two zeros. So this 0 is also has also been taken care of. Group number 8 takes care of this 0 and also this one over here, but this is a dunker. We don't care about dunkers. And then group number 9 covers this and this dunker, but again, we don't care about this. Okay, so this will be the first part. Now, this is where it gets a little tricky. What you need to do, or what I would recommend you to do, is that you redraw the map, but that you redraw it in a simple manner. So what I do is I draw a very little K-map. So let me go and do that. I'm gonna put a little K-map over here. So this is our K-map. And I'm gonna put on this K-map the zeros that have not been covered by the essential groups. So which are those zeros? So we go to the original map and we find the zeros that have not been crossed. So this is the first zero that I find, so I put it here. Okay. I also have this zero over here, and I put it, I'm sorry, this is the one that I already said. But I also find this zero over here, so I have another zero over here. On the right side, I find no zero that is not being taken care of, because this is already crossed, this is already crossed, this is already crossed. So this would be my new map. Now, notice how this map is very, very simple. And this one here is very difficult in terms that we have a lot of annotations over here. So that's the reason why we do this. Why we do this, because what the algorithm says in the K-map is that you need to find as least groups as you can that cover all the zeros. So again, these 4 must be part of the solution. So we already have 4 groups, and these 4 groups cover all the ones that are crossed. But we still have to cover these 2 zeros. Now, what you need to find is all the possibilities that we can cover those zeros. Why all the possibilities? Because all the remaining groups are not essential. They must not be part of the solution, but they can be part of the solution. So what you need to do is you need to try to find all the possible solutions. So what I like to do is I like to do the following. First, I start with the first zero that I find, which is this one here, and I go and see that zero on the original map. So this is over here. So for covering this zero, we have top 2 possibilities. We have the possibility of taking care of this zero with group number 3 or with group number 4. So what I like to do is I like to do a branching system, like a series of branches. And I put a lot of them because I don't know how many solutions there are, but I'm going to try to explore them all. So one possibility, again, to cover this zero that I haven't covered is to try to group number 3. So if I group number 3, if I take group number 3, you need to cross this here. Notice how I put a cross over there. Now, why I don't do this in this K-map? Because this K-map is the final one. And this over here is an exploration of possible solutions. So maybe I make a mistake. It doesn't matter. I can redraw the K-map. Okay? And actually, I'm going to copy this one over here. Notice how I copied the same K-map 4 times. Now, you don't need to do this on the exam. You can do this as you go and try to find a different solution. Okay, but I just made a copy so to make it a little faster. So again, I try for the first solution. So the first branch, which is also over here, is going to be this K-map. So again, when I decide to put number 3, I cover D0. Okay, so next, if I have already covered D0, the only thing that I have left is to cover D0. Okay, notice, is the 0 here, which is the 0 here. So again, I have 2 choices. I have the choice of putting group number 5 or group number 10. And again, what I like to do is as if I had chosen one, which is the group number 5. So if I choose the group number 5, I cover this one here. So that's it. That's the first solution. Now, one possible question is, what happens if I include also group number 10? This is not correct. Why not? Because group number 5 covers D0. This is the importance of making this annotation. We have already taken care of D0 by taking into account group number 5. So don't add group number 10. With this solution, which is by taking group number 6, 7, 8, 9, 3, and 5, this covers all the zeros. And you will see eventually that there is no other way to covering all those zeros with less groups. If someone says, my solution is 6.7.8.9, it would be wrong. because you have not covered all the zeros. You would be lacking these two zeros. But by adding group number 3 and group number 5, I already covered those zeros. Now, this is why we made a copy over here. Remember, we chose to put group number 3. But what happens if we choose differently? What happens if instead of putting group number 3, we put group number 3? I'm sorry, instead of putting group number 3, which is this one here, we put group number 4. Well, if we put group number 4, then, and this is why I do a different map, then I cover this zero. Okay, this one here. And again, I have the two options to put either group number 5 and group number 10. So I decide to put maybe group number 5 again. And this would be my second solution. Now, notice how over here we have two different functions or two different ways that we say, okay, we can either take group number 3 or 4, but at the end we take group number 5. Okay? But also another possible solution, and again, remember that by putting group number 5, I forgot to put a mark over here. But what happens if, again, I go with group number 3? But instead of going after picking the number 3, by picking number 3, I'm going to cover this 0 here. But what happens if instead of picking number 5, I pick number 10? So that would be a different solution. Do you notice how the terms are not the same? They're different. So this would be another solution. And what happens if instead of putting group number 4, and then putting group number 5, what happens if I also put group number 10? And you will see that there are no other way of finding or covering all those zeros with a different combination. Okay, so there is no fifth solution. There's not going to be a fifth solution. So in order to make this clearer, I'm going to erase this one here. So these would be my 4 solutions. An easier way to writing this would be the following. Again, after group number 9, I have the option of choosing between 2 groups. For covering this 0, I have the option of putting group number 3 or putting group number 4. And then after I chose either 3 or 4, I multiply this by another 2 options. I go either with group number 5 or group number 10. Now, you could think that these are 2 solutions, but these are actually a different way of putting 4 different solutions. Because again, one solution would be 6, 7, 8, 9, 3, 5. Another would be 6, 7, 8, 9, 3, 10. And the other 2 would be 6, 7, 8, 9, 4, 5, 6, 7, 8, 9, 4, 10. Those would be the four solutions of this problem. Hopefully you have understood how you can solve a K-map, and most importantly, how to find all the possible solutions. What I did again was here, all these 4 groups are, they must appear. And notice how all those over here are optional. Because you can see that in some solutions, group number 3 does not appear. When you have 2 solutions in which group number 3 does not appear, when you choose 6, 7, 8, 9, 4, and 5, or 6, 7, 8, 9, 4, and 10. Those are 2 solutions in which number 3 does not appear. That's why this group is optional. Sometimes it can appear, sometimes it doesn't. Notice another thing. Notice what happened with group number 1. Do you remember? Group number 1 was a big group, a group of 4. But we have not included that group as part of the solution. The reason why is because that group does not help us to cover any 0. It only covers dunkers. That's why I said at the beginning of this video that if you choose not to put this group, it is okay, because at the end, this group will not appear. First of all, because it will not have an asterisk inside of it. That's why it is not on this part of the final function. And lastly, it is not on this part of the function because this group does not help us cover any zero. It only covers dunkers. And we don't care about grouping dunkers in the end. At the end, all that it's missing is finding the expressions of all the groups, okay? So I'm not going to cover this on this video. I was more concerned about how to find all the possible solutions, but I'm going to do one simple exercise. So what you need to tell me at the end would be this. This would be the final answer, but you also need to tell me all the group functions. So you would need to tell me something like 6. And I'm going to do, let's say, group number 7. So what is the expression of group number 7? So you need to find the variables that cut this group. Now here, since this is a lonely zero, variable x does not cut this group. Remember, this is the line that can cut a group, or this one here for variable x, or this one here. For variable y is this here, and this line does not cut group number 7, neither this line, which is the same for variable y, and this line. For variable zeta, this is the line, and this over here. So these two lines does not cut, they do not cut this group. And finally, group w it would be this over here. So this line over here, this line over here, and this line over here, they do not cut this group. So what this means is that variable w, x, y, and zeta, they all must be part of this group. So w, x, y, zeta. Another thing is that since we are with product of sums, there must be an OR between each variable. And what about variable b? So variable b, it actually cuts this group because this group, group number 7, is actually these two zeros. So this line cuts these two groups. Okay? Another way to see variable b it would be, for instance, for group number 4. For group number 4, this is the group. So the question is, variable b cuts this group? And the answer is no. This does not cut this group because it is only on one part of the map. But group number 7 is on both sides of the map. So since they are on both sides of the map, variable b cuts this group. And because it cuts it, it does not appear on the expression. And finally, whether or not these variables are inverted or not. So for variable w it's equal to 1 over here. So this would be 1. W is equal to 0 over here. So since in this cell w is already 0, we leave it like this. For variable x, x is equal to 1 in these 8 cells, so it's equal to 1 in this cell. So x is 1, but we want the function to be 0, so we need to invert x. For variable for variable y is 0, so we leave it like this. And finally, for variable zeta is 1 in this cell, so we need to invert it. So this would be the final expression for group number 7. Again, you would need to do all the expressions for all the groups. Thank you very much. Hope you have understood better how to solve a K-map. See you next time.